NX is a numerical computing library for Elixir, designed to bring machine learning and numerical computation capabilities to the Elixir ecosystem. It serves as the foundation for Elixir's growing ML ecosystem by providing multi-dimensional arrays and just-in-time compilation to CPUs and GPUs, enabling efficient, scalable, and performant ML workflows. How NX helps Elixir perform machine learning, integrating insights from available sources while critically examining its role. 1. Providing tensors for numerical computations. What NX does, NX introduces multi-dimensional arrays called tensors, which are the core data structure for ML. Tensors allow Elixir developers to represent and manipulate data like images, datasets, or neural network weights efficiently. Unlike Elixir's native numeric title lists, tensors are optimized for numerical operations and can handle large, multi-dimensional data. How it helps ML. Most ML algorithms rely on matrix and tensor operations, e.g., matrix multiplication, dot products. NX provides a unified API for these operations, similar to NumPy in Python or JAX, making it possible to implement ML algorithms in Elixir without relying on external languages like Python. For example, NX supports operations like addition, multiplication, and reshaping of tensors, which are critical for tasks like linear regression or neural network computations. Example, a tensor can represent an image as a 3D array height, width channels. NX allows operations like NX add tensor and tensor or NX dot tensor and tensor to perform computations efficiently, which are foundational for ML models. 2. Just-in-time compilation with XLA. What NX does, NX integrates with XLA Elixir bindings for Google's XLA accelerated linear algebra compiler that transforms numerical definitions into optimized machine code for CPUs, GPU, or TPU. This JIT compilation ensures that computations are highly performant by leveraging hardware acceleration. How it helps ML workloads involve computationally intensive operations, e.g., gradient calculations, matrix operations. XLA compiles these operations into native code, significantly speeding up execution compared to running them on the airline VM beam, which isn't optimized for numerical tasks. For instance, benchmarks show NX with XLA on a GPU can be up to 4,760 times faster than pure Elixir for certain tensor operations. 3. Functional programming paradigm for ML. What NX does, NX adopts a functional programming approach, inspired by JAX, where computations are expressed as immutable, composable functions. This aligns with Elixir's strengths in functional programming and makes ML code easy to reason about and maintain. How it helps ML. Functional programming provides clean abstractions for ML tasks like gradient computation and model training. NX's def and macro allows developers to define numerical functions that are automatically differentiated for gradient-based optimization, the key requirement for training ML models. This avoids the complexity of object-oriented ML frameworks while leveraging Elixir's concurrency and fault tolerance for scalable ML pipelines. 4. Foundation for higher-level ML libraries. What NX does, NX serves as the backbone for libraries like Axon for neural networks, Scala for traditional ML, and Bumblebee for pre-trained neural networks. These libraries build on NX's tensors and compilation capabilities to provide high-level APIs for specific ML tasks. How it helps ML. Axon enables the creation and training of neural networks in Elixir. It uses NX tensors for model parameters and computations, allowing developers to build models. Axon handles model initialization, training loops, and inference, all accelerated by NX and XLA. Scala provides traditional ML algorithms, e.g., regression, clustering built on NX, making them GPU-ready and distributable. This allows Elixir developers to implement algorithms like k-means clustering or linear regression without external dependencies. Bumblebee integrates pre-trained models, e.g., from Hugging Face into Elixir, using NX to handle tensor operations for tasks like text generation or image classification. For example, Bumblebee can run GPT-2 or Whisper models with minimal setup. Example, using Axon, a developer can train a neural network on the MNIST dataset, where NX handles the underlying tensor operations and XLA accelerates the training. 5. Integration with Elixir's ecosystem. What NX does, NX leverages the Erlang VM's strengths, concurrency, scalability, and fault tolerance through features like NX serving. This allows ML models to be deployed in production within Elixir applications such as Phoenix Web App or NERSC-based embedded systems. How it helps ML. NX enables seamless integration of ML into Elixir's robust ecosystem. For example, Phoenix ML models can be embedded in web applications for real-time predictions, e.g., image classification in a web app. Livebook, interactive notebooks built on NX allow data exploration and model prototyping, similar to Jupyter but with Elixir's concurrency. Nerves, NX enables ML on embedded devices, such as running models for signal processing on IoT hardware. Broadway, NX supports concurrent data pipelines for real-time data processing and ML inference. 6. Data handling and ecosystem support. What NX does, NX integrates with libraries like SIData for datasets like MNIST or CIFR and Explorer for data manipulation like Pandas. These provide data processing and loading capabilities essential for ML workflows. How it helps ML: SIData simplifies loading and normalizing datasets into NX tensors, while Explorer offers data frame support for data wrangling. This ensures Elixir developers can handle the entire ML pipeline data ingestion, preprocessing, model training, and deployment without leaving Elixir. 7. Interoperability with other ML frameworks. What NX does, NX supports integration with formats like ONCs via Ortix or Axon ONCs and TensorFlow Lite, allowing developers to import pre-trained models from Python-based ecosystems or export Elixir models for use elsewhere. How it helps ML: this interoperability bridges the gap with Python's dominant ML ecosystem. Developers can train models in Python, export them as ONCs, and deploy them in Elixir for production, leveraging Elixir scalability. Conversely, NX models can be exported for use in other frameworks. Example: a pre-trained Wishbone model can be imported via Bumblebee and run in Elixir for speech recognition, with NX handling the tensor computations. Critical analysis and limitations. While NX significantly enhances Elixir's ML capabilities, it has limitations. Maturity: NX and its ecosystem Axon, Scholar, Bumblebee are relatively young compared to Python's TensorFlow or PyTorch. Features like distributed training or advanced checkprinting are still in development. Community and adoption. Python dominates ML due to its fast library ecosystem and industry adoption. Elixir's ML community is smaller, and NX is better suited for deployment than research-grade model training. Performance: while NX with Elixir is fast, some model architectures, e.g., transformers, may not yet be fully optimized compared to Python frameworks. Despite these, NX's functional approach, integration with Elixir's concurrency, and growing ecosystem make it a compelling choice for production ML, especially for real-time, scalable applications. In summary, NX empowers Elixir for machine learning by providing tensors, JIT compilation, and a foundation for libraries like Axon, Scholar, and Bumblebee. It enables developers to build, train, and deploy ML models entirely in Elixir, leveraging the language's strengths in concurrency and scalability. While not yet a rival to Python for research, NX excels in production use cases such as embedding models in web apps or EOT devices, and its interoperability ensures flexibility. For example, a developer can use NX to implement a linear regression model, train a neural network with Axon, or deploy a pre-trained GPT-2 model with Bumblebee, all while staying within Elixir's ecosystem.